Hello everyone. Once again, welcome to PM Networking. Hope you all are doing great. Guys, today in this video, we are going to understand OSPF deployment over DMVPN. OSPF deployment over DMVPN. I am talking about DMVPN phase 3. Guys, DMVPN phase 3 is already configured on all these devices. I will show you the configuration, like what configuration are there, on the tunnel interface of hub router, spoke 1 and spoke 2. Don't worry, I will show you the configuration. But DMVPN phase 3 is pre-configured over here. And on the DMVPN, we are going to run what? OSPF. And guys, before starting the session, I would like to tell you something about OSPF. Like whenever you are implementing OSPF over DMVPN, you need to keep this point in your mind, right? So guys, we have one recommendation. What is the recommendation? Recommendation is this, that whenever you are implementing OSPF, right, over the DMVPN, so if your DMVPN network size is large, you should not implement OSPF as dynamic routing protocol. What I am saying, it is not recommendation to implement OSPF over large DMVPN network, right? Don't worry, you will understand in this video that why this is a recommendation, like we should not implement OSPF over large DMVPN network. Just let me give you one example over here, right, to make it clear. Let's assume, guys, this is very large network. There are lots of network connected with spoke 1, and there are lots of, let's say 100 branch offices are there, multiple hub routers are there, right, or 2 hub routers are there. And just assume that whenever one network will goes down on a spoke 1 or a spoke 2, or whenever we will add a network, all routers in a DMVPN are going to recalculate SPF, right? They are going to rerun the SPF algorithm. And guys, whenever router are running SPF algorithm, right, they are using their CPU utilization. Let's assume the database of hub router is very large. There are lots of LSA1, LSA2, LSA3, LSA4, like that, right? And if this router is running SPF algorithm again and again on their database, definitely CPU utilization of your hub router will get increased. So this is one reason, right, why we should not implement OSPF over the large DMVPN network. You can configure the EIGRP, you can configure the BGP, no problem at all. But again, if your network is small, if your DMVPN network is small, then definitely you should go with OSPF only, because OSPF is a good routing protocol and most of the companies are using it, right, over the DMVPN. The another reason why we should not implement OSPF in large DMVPN network is what? Summarization. Guys, we don't have much option for the summarization in OSPF over DMVPN, right? So this is also one reason why we should not implement OSPF over large DMVPN network. Okay, now let's begin the session, guys. See, without starting the session, one more thing I want to tell you. That thing is, see, whenever you are going to implement OSPF over DMVPN, or doesn't matter in which network you are going to implement OSPF, right? Before implementing the OSPF, let's suppose you are configuring OSPF between router 1 and router 2, between router 1 and router 2 only, right? Both are directly connected with each other. So you should figure out here, right? You should figure out first that what network type you are going to configure here, right? In the same way, in this network also, if I am going to implement OSPF, if I'm going to deploy OSPF over here over the DMVPN, first thing that I need to figure out is what network type I am going to configure, right? Like guys, in this scenario, in my topology, either I can configure network type what? I can configure point to point, I can configure broadcast, I can configure non-broadcast, I can configure what? Point to multi-point, point to multi-point, non-broadcast. You can configure any network type. Definitely you cannot configure point to point over here, right? Because in DMVPN, tunnels are multi-point. Tunnel interfaces are multi-point. So we cannot configure point to point. Yes, you can do one thing. You can, technically we can say that here on the hub router we can configure what? Point to multi-point. Sorry, point to multi-point on the hub router. Point to multi-point. And on the spoke routers, right, we can configure what? Point to point. Technically this is correct, but problem is what, guys? Timer. hello time and date time of this network type is different, and hello and date time of this network type is different, right? So if timer will match, that means hello parameters are not matching. If hello parameters will not match, then neighborship will goes down, right? So this is the problem. This is the reason why you cannot configure point to point even on the spoke routers. Getting my point? So hope it is clear. And in DMVPN phase 3, your spokes tunnel are also multi-point, right? Here also tunnel interface is going to be what multi-point. Here also tunnel interface is going to be what multi-point, because we have configured what DMVPN phase 3. Okay. So guys, before implementing OSPF or the DMVPN, you need to figure out which OSPF network type we are going to use. Like, we can not use point to point in the DMVPN as the tunnel is multi-point. We can configure point to multi-point on the hub router, and we can configure the point to point on the spoke router, but still we have problem, right? Because of timer. So what network type here I should configure? Either I can configure what, guys, point to multi-point. I can configure the point to multi-point, but you know, this is simple configuration, point to multi-point, and this is the recommendation as well. This is the recommendation that whenever you are configuring OSPF or DMVPN, network type should be what? Point to multi-point, right? This is the preferred one. Then point to multi-point non-broadcast, point to multi-point non-broadcast. We can configure this one as well, point to multi-point non-broadcast. But guys, what is the problem? See, point to multi-point non-broadcast and point to multi-point, both are same. But here in the point to multi-point non-broadcast, it is similar like point to multi-point, but here we have to configure static neighborship. Here we have to configure what? Static neighborship. If you want dynamic neighborship, then you have only this option, point to multi-point. Then the third network type can be what here? Broadcast. I can configure broadcast, but again, what is the problem in broadcast? Broadcast is also fine, it will work fine, right? But guys, this is not recommendation, because it will work good, but not usually recommendation, because we have to pay a special attention on DR and BDR election. If network type is broadcast over here, right, then guys, only hub router should be my DR router, and spoke router should be DR other router. So you have to pay a special attention for DR and BDR router, right? So that's why again, we are generally not using broadcast network. Okay, so you can configure the broadcast as well, but if you are configuring the broadcast, make sure your hub router is DR, because guys, just assume if a spoke router is going to become DR, if this router will become DR, then what will happen? This, let's say this one is DR other, this one is also DR other. So DR others are going to share their database with DR router, right? And there is only OSPF neighborship, there is only OSPF neighborship, there is no any OSPF neighborship between spoke 1 and spoke 2, right? So spoke 1 router cannot share their prefixes to hub router, because this is DR other, right? That means spoke 2 will never get this network information, right? So that's why if you are configuring broadcast network type, then make sure your hub router is going to become what? DR. And I will do same thing, guys. When I will start the configuration, first I will set the network type what? Broadcast. Here you will see the problem. Okay, then you can configure non-broadcast as well, non-broadcast, which is similar like broadcast, but again here problem is what? Static neighborship. You have to configure static neighborship. So the best option, which network type I should configure in this scenario? Point to multi-point, right? Point to multi-point. Guys, if I will talk about the other consideration while implementing OSPF over DMVPN, so what can be the other consideration is, as you can see, as all the routers will share same subnet, right, over the tunnel. Like here we are running IP what? 192.168.10.1. This is the subnet which I am running on overlay network. Overlay network is like this, right? Guys, on this overlay network, I am running this subnet 192.168.10.0/24, right? So all tunnels are sharing single subnet, right? Here IP address is .1, here IP address is .2, here IP address is .3. So as these all tunnel are connected with single subnet, these all tunnel interface should be in same area, right? These all interfaces should be in same area, then only OSPF will work fine. Let's say here if you have defined area what? 0, and here you have defined area 1. Now OSPF is not going to work fine here, right? So all the routers should be in same area, as all the tunnel interfaces are sharing single segment, right? And as all the tunnel interfaces are sharing same subnet, means OSPF database of these all routers are going to be identical, right? Going to be same. And again, this is not good for summarization. This causes summarization issue, which is acceptable in a small network, but it is not acceptable in large network, right? So this is again the one reason why you should not implement OSPF in the large DMVPN network. One reason why OSPF is usually never recommendation in large DMVPN network is what, guys? This one, summarization. Okay. So first of all, I'm going to set network type port broadcast. So if you are configuring network type broadcast, make sure hub router is your DR router. So what you can do on the hub router, you can set the priority. You can run this command IP OSPF priority 255. And on the spoke routers, you can run command what? IP OSPF priority 0. So this router will not participate in DR and BDR election. And after that, you should configure OSPF. First is what? You need to define the network type. You need to define the priority, right, on all the tunnel interfaces. And then you should turn on the OSPF protocol. See guys, in this scenario, if I am going to run OSPF here, and before running the OSPF, I want to show you the tunnel interface configuration. So like on hub router, so run interface tunnel 1. So you can see guys, tunnel 1 configuration. Interface tunnel 1, IP address 192.168.10.1, 255.255.255.0, no IP redirect, IP NHRP map multicast 22.1.1.1 and 33.1.1.1. 22.1.1.1 is the NBMA address of spoke 1, and 33.1.1.1 is NBMA address of spoke 2. Correct. Here I can use the dynamic keyword as well. I can remove this command and I can use dynamic keyword. Then IP NHRP network ID 1, tunnel source, and then tunnel mode is what? Multipoint GRE. In the same way, you can verify the configuration, tunnel interface configuration on a spoke 1. So run interface tunnel 1. So you can see tunnel 1, IP address 192.168.10.2, 255.255.255.0, IP NHRP map. I'm mapping the destination IP address with NBMA address. Then IP NHRP map multicast to the NBMA address of hub router. After that, we have enabled the NHRP protocol. We have defined the NHS address, next hop server address, then tunnel source, and then mode. Mode is again here what? Multipoint. On spoke 2, so run interface tunnel 1. So here also you can see configuration is same, only IP address is different, right? Rest configuration are same, exactly same like spoke 1. Fine. Now guys, on hub router, either you can map the multicast to a particular NBMA address, or you can run the dynamic keyword here, right? I can remove this entry interface tunnel 1 and I can run this command IP NHRP map multicast dynamic. This keyword will also work fine. Let's say you have lots of branches or spoke routers, then you will run this command, right? Because putting a single command for each spoke can be complicated, right? Now guys, let me configure the OSPF, and before configuring the OSPF, we should verify the connectivity. ping. I'm going to ping the tunnel remote tunnel IP address 192.168.10.2 spoke 1. Yes, I am able to ping, and spoke 2. Yes, I am able to ping the spoke 2 as well, right? So there is reachability. That means we can establish a OSPF neighborship over here. And as I told you, before configuring, before enabling the OSPF, you should do what? You should configure the priority on interfaces. You should change the network type. But guys, let's suppose if I'm not going to set the priority on interfaces, or if I will not set the network type, and if I will enable the OSPF, then what will happen? Router OSPF 1, and say router ID is what? 1.1.1, and then interface, and let me set the router ID on all the routers. Router OSPF 1, and say router ID 2.2.2.2, and router 3 means spoke 2, say router OSPF 1, and router ID I am going to set here 3.3.3. Now I'm going to enable OSPF on tunnel 1 interface of is hub router. Interface tunnel 1, say IP OSPF 1, let's say area what? 10. On spoke 2, interface tunnel 1, say IP OSPF 1 area 10, and then spoke 2, interface tunnel 1, interface tunnel 1, IP OSPF 1 area 10. Done, guys. So we have now OSPF neighborship. You can see over here. So IP OSPF neighbor, right? Neighborship is in X start state, right? Let me take you to hub router. Yes, on the hub router, guys, you can see I'm getting log message adjacency forced to restart. This is again because of network type, because by default network type on the tunnel interface is what? Point to point. So run so IP OSPF interface tunnel 1, so IP OSPF interface tunnel 1, and then we can say include network type. So you can see, guys, network type is what? Point to point on the tunnel interface. On router number 2 also you can verify, means on spoke 1, so IP OSPF interface tunnel 1, and then we can say what? Include network type. So network type is what? Point to point. So this is the reason why my OSPF neighborship is flapping over here. So IP OSPF neighbor, right? With 2.2.2 neighborship is full. After some time you will see with 3.3.3 neighborship is full, right? 3.3.3 X start state, right? So my neighborship is flapping just because of network type. So what we need to do here? We need to set the network type what? Either I can set the broadcast, non-broadcast, point to multipoint, non-broadcast. So if I am configuring point to multipoint, right, then everything will work fine. If I will configure the broadcast, then I have to make sure that my hub router is the DR router. And if you are configuring point to multipoint non-broadcast or non-broadcast, in these two scenarios you have to configure a static neighborship. Correct, guys? So now let me do one thing. First of all, I am going to configure broadcast network type here. Interface tunnel 1, IP OSPF network, let me say broadcast. Go to spoke 2, means spoke 1, interface tunnel 1, say IP OSPF network broadcast. Then spoke 2, interface tunnel 1, and say IP OSPF network what? Broadcast. Right? Now guys, see, so IP OSPF neighbor, everything is working fine. Soon neighborship will come in full state. It will take some time. You have to wait for some time. And 2.2.2 is DR other for now. 3.3.3 is also DR other for now. Now you can see 3.3.3 is your DR router, right? So this is problem here. Now you can see OSPF neighborship is there, full state, right? I can run command, so IP OSPF neighbor. And which router is DR router? 3.3.3. Which router is BDR router? 1.1.1, because 2.2.2 is DR other. And guys, if I will set priority 0, let's say on hub router, so that it cannot become the BDR, right? Because let's say there are multiple branches. So one router, one spoke router is DR and another spoke router is BDR, right? And then what will happen, guys? Like this, in this scenario also, if you can check the routing table, so IP route OSPF, I don't have any route. Why I don't have any route, guys? Because we have not advertised the LAN interfaces in OSPF. So let me do one thing. Let me enable OSPF on LAN interfaces as well. So interface range loopback 1 to 4. I'm going to enable OSPF here, right? Say IP OSPF 1 area 10. On spoke 1 also, interface range loopback 1 to 4. Say IP OSPF 1 area 10, and then spoke 2, interface range loopback 1 to 4, say IP OSPF 1 area 10. Now go to hub router and let me verify the routing table. So IP route OSPF. Now you can see I am learning all 20 prefixes. Soon I will learn all 30 prefixes as well. Yes, you can see I am learning all 30 prefixes. Yes. Go to spoke 1. On the spoke 1, so IP route OSPF. See guys, I'm learning the 10 as well as I'm learning the 30. Actually, why this spoke 1 is learning 30? Because your hub router is BDR router. So IP OSPF neighbor. So IP OSPF neighbor. You can see this one is BDR. So let me do one thing. On the hub router, I am going to set priority 0 for some time. Interface tunnel 1, IP OSPF priority 0. Right now, clear IP OSPF process. Say yes. So IP OSPF neighbor. So IP OSPF neighbor 2-way. Soon it will come in forwarding state. So IP route OSPF. Okay, fine. Now this time 1.1.1 is DR other, right? Yeah, we have full neighborship, and 1.1.1 is DR other. Now you can check the routing table. So IP route OSPF. So IP route OSPF. We don't have any prefixes. Why? Because hub router is what? DR other router. Other router spoke 1 is also what? DR other, and spoke 2 is my DR router, right? So guys, DR other is going to share their database to DR router, right? And DR router is going to share the database, means complete database, to DR other routers, like to spoke 1. But here we don't have OSPF neighborship. So this is the problem with broadcast network type. If we are running network type broadcast, then hub router should be only DR router. Otherwise you can see the problem in front of you, right? And on the spoke 2, you can check the routing table. So IP route OSPF, it have learned only 10 networks, right? Not 20 networks. Why? Reason is what? Spoke 1 is not sharing their database to hub router, right? You can check the database table of hub router. So IP OSPF database, you can see there is LSA1 of 2.2.2. Wait, brother. So IP route OSPF, it is learning only 30. So IP OSPF database, there is LSA2 from 10.2 as well as from 10.3. Okay, let me take you to spoke 2 and so IP OSPF database. Here you will not see LSA 1 of router means spoke 1. Why I'm getting this LSA here? That means router 1 is sending to hub router and hub router is forwarding it to the DR router. But this router should not advertise it. On a spoke 1, so IP OSPF database. Database is identical of all the routers. But I think there is some guys, there means on the hub router and on a spoke 2 router, we should not have the router LSA of spoke 1 means from the 2.2.2 because as hub router and spoke 1 both are DR other router, these routers are not going to exchange database directly. On spoke 1, so IP OSPF neighbor, so IP OSPF neighbor, yes, we have neighborship with 1.1.1 only, which is DR other router, right? Maybe that entry is the previous one, previous entry, right? Let me do one thing, let me clear IP OSPF process once again here, and now so IP OSPF neighbor. Now it will take some time. You can see with 3.3.3 neighborship is full, with 2.2.2 neighborship is in two state. So IP OSPF database. If I will open this database, this router LSA in detail, let's say a router LSA of 2.2.2.2. So it is sending these all prefixes. I think this is because of simulation software only, right? This is because of simulation software, but because technically guys, hub means spoke 1 and hub, the relationship OSPF relationship between spoke 1 and hub is till two-way only, right? Till two-way only, should be till two-way only, right? Because both are DR other, so IP OSPF neighbor, yes, we have neighborship till two-way, you can see here, but still both routers are exchanging database with each other. So maybe this is because of simulation software. So IP OSPF database, yes, okay. But now these two branch offices cannot communicate with each other. Even a spoke cannot communicate, means these LAN user 10 networks cannot communicate with 20 networks, because in the routing table of hub, so IP route OSPF, we don't have 20 network, right? On the spoke 1, so IP route OSPF, we don't have any route like 10 network or 30 network. On a spoke 2, so IP route OSPF, we have only 10 network, we don't have 20 network. If we will form OSPF neighborship between guys spoke 1 and spoke 2, then what will happen, and how we can form the OSPF neighborship over here? Because some people are thinking what, that I can do one thing on a spoke 1 router, on this tunnel interface tunnel 1, I can run one more command, IP NHRP map multicast to 33.1.1.1, and on spoke 2 I can say interface tunnel 1 IP NHRP multicast map multicast to 22.1.1.1. Now you can see we have OSPF neighborship here, so IP OSPF neighbor. On spoke 2 we have neighborship with 1.1.1 as well, with 2.2.2 as well. Now this is what, this is full mesh topology. Now we have OSPF neighborship between spoke 1 and spoke 2 as well, so now we don't have any problem, right? Now you can see here on spoke 1, so IP route OSPF, yes, I'm learning all 10 networks and 30 networks, getting my point. The reason is what, reason is we have neighborship, right, between spoke 1 and spoke 2. This is full mesh topology. So if you have full mesh topology, then you can configure the network type broadcast, but in the hub and spoke topology you cannot configure the broadcast. If you are configuring broadcast, then make sure your hub router is DR router only. So how I will fix it, guys, how we will resolve this issue with network type broadcast? First of all, I am going to remove this command from tunnel 1 interface, say this command to no, just to make this topology as hub and spoke topology interface tunnel 1, and I'm going to say no to this command also. Again, OSPF neighbor civil goes down between spoke 1 and spoke 2, so IP OSPF neighbor, so IP OSPF neighbor, clear IP OSPF neighbor, sorry, clear IP OSPF process, say yes to this, and so IP OSPF set, so IP OSPF neighbor. Now we have neighborship with 1.1.1 only, right? And it is in two-way state, soon it will come in, sorry, on spoke 1, so IP OSPF neighbor. Here also you can see neighborship is in full state with 1.1.1. This is sometimes, these are problem of simulation software only. So IP OSPF neighbor. Okay, with 2.2.2 neighborship is still two-way state, with 3.3.3 neighborship is in full state because of DR, right? And now again on spoke 1, so IP.OSPF, you can see we don't have any. These are because of previous entries, so IP OSPF neighbor, this is problem of simulation software. Yes, here it's showing what? Full state with 1.1.1, right? But as both are DR other, there should be no any full neighborship between hub and spoke 1. Simply you can do one thing, you can run the clear IP OSPF process command here, right? So IP OSPF interface brief command also you can run, so IP OSPF interface brief. So on the tunnel interface area is fine. Here it's saying DR, right? This interface is DR, so interface F0/0, say IP OSPF priority what? 0 now. So I have set the priority 0 here. And guys, so run, let me check the tunnel interface configuration one again. I think mapping is there or not. Yes, mapping is there. Yeah, fine. So IP OSPF neighbor, now it will work fine. I think clear IP OSPF process, say yes. And now so IP OSPF neighbor, now neighborship will be till two-way state only, till two-way state only, right? And now this router will not get any prefixes, so IP.OSPF, got it? Okay, so okay, if you want to run the network type broadcast in hub and spoke topology, no problem, you can, but for that you have to set higher priority on the hub router and you have to set priority 0 on all spoke routers. So let me do it. Go to interface tunnel 1, and here I can run command IP OSPF priority what? 255, let's say IP OSPF priority 255, and on, sorry, I have set it to spoke 2. Okay, no problem, I will remove it. Interface tunnel 1 IP OSPF priority 255 on the hub router, on spoke 1 IP OSPF priority IP OSPF interface tunnel 1 IP OSPF priority 0, on spoke 2 also IP OSPF priority 0. Now which router will become DR router? My hub router is going to become DR router because hub router have a higher priority now. Okay, and as my all spokes are connected with hub router, right, they are going to form full neighborship, so IP OSPF neighbor. So you can see neighborship with 2.2.2 is full and 2.2.2 is DR other. Neighborship with 3.3.3 is full and DR. And what priority is running on 2.2.2 and 3.3.3? 0, right? So now guys, so IP route OSPF, here we have all 20 prefixes as well as all 30 prefixes. On spoke 1 also, so IP route OSPF, here you can see we have all 10 prefixes as well as all 30 prefixes. And on spoke 2 also, so IP OSPF, so IP route OSPF, we have 20 prefixes also and we have 10 prefixes also. correct? So now these branches can communicate with each other. From the spoke, I am going to verify the connectivity, ping 20.1.1.1 and say source 10.1.1.1. See, ping is working. I can ping 30.1 also, 30.1.1.1. See, ping is working. Fine. On guys, spoke router, ping 10.1.1.1, source 20.1.1.1, right? And now can these two branches communicate with each other? Yes. First time it will communicate via hub router because show IP route OSPF. You can see 430 network. 430 network from I am on a spoke 1 guys. So if let's say this LAN user from this network want to communicate with a user from this network, right? So for 30 network 30.1.1.0, what is the next hop? 192.168.10.3 means spoke 1 is going to forward traffic directly to spoke 2, right? Communication is going to happen directly like this, and prefixes is going to exchange like this, right? So in the broadcast network guys, if DR is your hub router, then we don't have any problem, right? So trace route 30.1.1.1, source 20.1.1.1 and say numeric. Yes, traffic is going directly because here we are running what? I shortcode command. On the hub router we are running what? Redirect command. Okay, so this is guys OSPF deployment over DMVPN with network type what? Broadcast. So as you can see, problem is with DR and BDR only. We have to pay special attention for DR and BDR election, right? Now the next thing is, let's say I have lots of prefixes guys on spoke 1, spoke 2 and the hub router. Then what we have problem? We cannot perform the summarization. We cannot perform the summarization. This is the problem here, right? So to perform the summarization, what you can do? You can advertise, let's say only and only you can perform some summarization on hub router guys, right? So what you can do, you can advertise these prefixes in different area, let's say area 0. So now this router will become what? ABR router, and on ABR router you can perform the summarization, right? You can perform the summarization. So like that you can configure it. You can put these all networks in different area, and after that you can perform the summarization. Now I am going to change the network type here from broadcast to multi-point. And guys, in point to multi-point network type, you will see OSPF will work fine. So let me do it. Configure T and say interface F0/0. Whatever command I have run here regarding OSPF, I am going to remove all, like IP OSPF network broadcast. I'm going to say no to this, right? Then no IP OSPF priority 255. In the same way on spoke 2 also, sorry, on spoke 1 I think priority was 0. Okay, on a spoke 2 interface tunnel 1, say no IP OSPF network broadcast, and then say no IP OSPF priority 0. Then let me take you to hub router. On hub router interface tunnel 1, say no IP OSPF priority 255 and no IP OSPF network broadcast. Done. Now again OSPF membership is flapping because of network type. So this time what network type I'm going to set? Point to multi-point. So let me take you to interface tunnel 1 and say IP OSPF network what? Point to multi-point. And guys, as I told you that technically you can configure point to point on the spoke router. So on the spoke router, if I will configure network type point to point, interface tunnel 1 IP OSPF network point to point, and on spoke 2 also IP OSPF network point to point. Then see on the hub router what problem will occur. So IP OSPF neighbor, we don't have neighborship. We don't have neighborship. Debug IP OSPF hello. See what it's saying. mismatch hello parameters from 190 to 168.10.2. So what parameter is mismatching, guys? Date time and hello time. Okay. So on the spoke router also you have to configure network type port point to multipoint. So IP OSPF network, we can say point to multipoint. On spoke 2, IP OSPF network point to multipoint. Now go to a spoke router and you can see you have no neighborship. So IP OSPF neighbor. So IP OSPF neighbor. Yes, we have full neighborship with 3.3.3 also, with 2.2.2 also. Here I don't need to take care about the DR because there is no concept of DR and BDR over point to multi-point network type, right? So IP route OSPF. So I am running 30 network as well as 20 network on hub spoke 1. So IP route OSPF. Yes, here also you can see I am running 10 as well as 30 on spoke 2. So IP route OSPF. Yes, I am running 10 as well as 20. So everything is working fine right here if my network type is point to multi-point. And guys, for the better configuration, what you can do on the hub router, you can make hub router as ABR router. You can make hub router as ABR router. Receive hello from 3.3.3 from the EIA tunnel this and of hello processing. Mapping is not working. So run section IP NHRP. Okay. So run section IP NHRP. NHS is correct, mapping is also correct, everything is fine here. So run section IP NHRP. Here also everything is correct. Ignore it for now, maybe this is because of simulation, because everything is fine, right? All configuration is correct, guys. So IP OSPF interface brief. So IP OSPF interface brief. So IP OSPF interface brief. And all. Now disable the debugging and so IP OSPF neighbor. And again you can verify the connectivity. So IP route OSPF. So IP route OSPF. So this router is running 30 network from which next hop? 190 to 160.10.1 via hub router, right? Via the hub router. But as we are running IP redirect command is there, IP NHRP redirect, first packet will go via hub router and second packet will go directly. So if I will trace route 30.1.1.1 and source 10.1.1.1, say numeric, you can see first packet is 20.1, not 10.1. First packet to hub router, then spoke. Second packet hub, then spoke. Means all traffic is going via hub router only here, right? So why this, guys? So run interface tunnel 1 IP NHRP redirect command is there or not? Not there, right? So let me do one thing. Interface tunnel 1, say IP NHRP redirect. Now go to spoke 1 and again trace route. So run interface tunnel 1 config T interface tunnel 1 and say IP NHRP shortcut. Config T interface tunnel 1, say IP NHRP shortcut, and again let me trace Okay, now you can see second packet is going directly, right? Okay, so IP SAF 10.1.1. Sorry, 30.1.1.1. You can see next hop is 192.160.10.1. Fine. So this is OSPF implementation our DMVPN with network type what? Point to multipoint. So guys, with point to multipoint OSPF is working fine. Now we have still two more types of network, right, in option that we can configure. But for now, just I want to show you some more configuration here. Like as I told you, to make hub router as ABR router, what we can do, we can change the area on loopback interfaces. Interface range loopback 1 to 4. And here I can say so IP OSPF 1 and let's say area what 0. Now this router will become what? ABR router. So IP protocol. You can see this router is now what? Your ABR router. It is an area border router. And from the spoke one also you can check what so IP OSPF border router. So which router is border router? 1.1.1. Which type of router is it? ABR router. And if you want to generate a default route right from the hub router, what you can do guys, here you can configure the DMVPN as a totally NSSA area, right? Again, if this concept is not clear to you guys, please watch my OSPF series. Again, if you want to learn OSPF in detail, you can purchase the OSPF course on website at very low cost, around 1000. At 1000 you can purchase the OSPF series and you can master the OSPF protocol like NSSA area, what is totally NSSA area, right? So guys, on hub router what we can do, on actually all routers I can configure what area 10 as stub means totally NSSA area, right? So say router OSPF area 10 because we are running area 10 on DMVPN, right? And then I am going to say what area 10 NSSA no summary, right? I have to run same command on spoke 1 as well as on spoke 2. So do so history. I'm going to copy this command and let me put this command on spoke 1 as well as on spoke 2, right? Now so IP OSPF border router, you can see this router is acting as ABR only. So IP OSPF, so IP OSPF database, so run section OSPF. Few things is not working on the simulation software, I think. Area 10 NSSA no summary. Now these prefixes are inter-area prefixes. So now you can summarize these prefixes, right, on hub router. Now you can summarize these prefixes on spoke 2 also. So IP route OSPF. So IP route OSPF. You can see these are now inter-area prefixes. So you can summarize these prefixes on hub router now, right guys? So for now what I am going to do, I am going to remove this command router OSPF 1. No need to remove, by the way. Simply we can change the network type here. Interface tunnel 1 IP OSPF network. IP OSPF network. What we can say? Let's say non-broadcast or point to multipoint non-broadcast. On spoke 1 also interface tunnel 1 IP OSPF network point to multipoint non-broadcast, and on a spoke 2 also interface tunnel 1 IP OSPF network point to multipoint non-broadcast. Now what will happen? So IP OSPF neighbor. See guys, you don't have no neighborship, right? So IP OSPF neighbor. So IP OSPF neighbor. So this time here you have to configure neighborship manually. See this type of error you will get. Right? Once data interval will become 0, this neighborship will delete this entry. Now guys, here to form neighborship, what we have to do, you have to configure a static neighborship, right? See how to configure a static neighborship. Router OSPF 1, and I can say neighbor. What is the IP address of a spoke 1 192.168.10.2? That's it. And same command I need to run on a spoke 1 also, router OSPF 1, and I can say neighbor 192.168.10.1, right? Now I am expecting OSPF neighborship between hub and a spoke 1. So IP OSPF neighbor. So yes, we have neighborship with 2.2.2, right? After 22 seconds, I think it will remove this entry. Okay, and now so IP route OSPF, I am running 20 network. Yes, I am running 20 network, you can say, right? And neighborship, yes, now you can see we have only one neighbor with 2.2.2. So again, to form neighborship with between hub and spoke 2, you have to configure one more entry, router OSPF 1, and say neighbor 192.168.10.3, and same thing on spoke 2 also. I can say what, router OSPF 1 and then neighbor 192.168.10.1, right? Now again I am expecting one more neighborship here, so IP OSPF neighbor. Fine, just wait. Yes, you can see now. Okay guys, and so IP route OSPF, I'm learning 20 as well as 30 on a spoke 1. So IP route OSPF, these are inter-ERP fixes, right? And again you can verify the connectivity. Ping 30.1.1.1, source 10.1.1.1. Ping is working fine. Note 10 20.1.1.1. Again I'm doing same mistake. Yes, see, ping is working, right? So guys, this is OSPF deployment over DMVPN, right? Again, this is basic configuration. If you need advanced configuration of it, or if you need any other protocol configuration like BGP, EIGRP over DMVPN, please let me know in the chat section. Definitely I will make one video on that. If you have any question from this class guys, from this session, anything that you have not understood, please let me know in the comment section. Definitely I will make one short video on that. Fine, that's all for today. If you have learned something from this video, please hit on like button. If you haven't subscribed my channel guys, please subscribe this channel. We will meet soon in next video. Till then, stay safe. Bye bye. That's all for today.